Welcome to another exciting edition of my boring math videos. Today we'll be talking about imaginary numbers. So let's just get to it. There was a time where mathematicians had to invent numbers, and they're usually to actually solve particular equations that are unsolvable. Imagine if we did not have negative numbers. If we didn't have negative numbers, this equation right here would not have a solution. If in fact there were no negative numbers. So at one point in time, mathematicians had to actually invent numbers for it. So that's why we can actually do all of this good stuff to this to get a what is called a negative number. So that's how we ended up with that. Later on, it came a point we had another equation that was also unsolvable. So for example, you look at this has a lot to do with what we're doing now. There was a point in time where this was unsolvable. So what they did was invent what we call irrational numbers to make that solvable. Now remember that when we used to take the square root of both sides, if in fact we tried to take the square, you'd get square root of 2, which is not a whole number or a rational number. So they came up with what's called irrational numbers to actually solve that. So we come to this point where mathematicians had to come up with a number to make that solvable. Now notice what happens when we try to solve this. Once again, it's taking the square root of both sides, right? So this was a problem that mathematicians came up with, or that they had, that we had to figure out. Let's invent something to make that solvable. So let's talk about that for a little bit. Remember how I used to always say that an equation that looks like this has no real solution. Not no solution, but no real solution. And the reason why is because if in fact you do take the square root of both sides, you cannot take the square root of a negative number. So what we did was we actually came up with a result for that. And what we did is we came up with imaginary numbers. So that's where I was invented. Well, the number I. And all I is just the square root of -1. So when they came up with that number, it opened up a new world of mathematics with imaginary numbers. So all we're doing is accepting the fact that I equals the square root of -1. So now watch what happens. Let's say we square I. When we square I, that's just square root of -1 times the square root of -1. The square roots cancel out, you just get -1. If we cubed I, that's just I times I squared, which will give you -I. The reason why is because if you have I times I squared, then you're just going to have, remember what I squared is -1. So really you have I times -1, which is just -I. So once again, what happens with I to the fourth, which is just I squared times I squared. And since I squared equals -1, I to the fourth is going to be 1. Now watch what happens as we go further. If we look at I to the fifth is I squared times I cubed, which is just -I times -1, which is just going to give us I, or the square root of -1, right? So then when we go to I to the sixth, I cubed times I cubed, we're going to get -1. I to the seventh, if I'm following my pattern, is going to be -I, and I to the eighth is going to be 1. So as you can see, there's a pattern that goes every 4 of them. So from I to I to the fourth, it's that pattern of square root of -1, -1, -I, 1, and it repeats and resets from I to the fifth to I to the eighth. When you do I to the ninth, it does it all over again. So let's keep on moving with examples of them. The only direction you'll get here is to simplify. So let's look at the square root of -5. Remember, at one point in time, we thought that there was no solution to this. There's actually no real solution to this. But this actually breaks up into two different roots. Negative 5 just equals negative 1 times 5. So now we can split that radical to get the square root of negative 1 times the square root of 5. And the square root of negative 1 is just I. So what we get is I times the square root of 5. If we keep on going, let's look at the square root of negative 25. Once again, this breaks into negative 1 times 25, right? That breaks into two separate radicals, square root of negative 1 times the square root of 25. Now, the square root of 25 is just 5, and the square root of negative 1 is I. So what we get in this case is 5I. One more, if you talk about the square root of negative 50, that splits up in three ways. We take out the 25, we take out the 2, and we have the negative 1. So what ends up happening is what comes out of here, what comes out of the square root is we can take out this and we can take out this. The 2 has to stay. When we take the negative 1 out, that becomes I. We take the 25 out, that becomes 5. We can also split it into these three radicals. You know what this is gonna be, and you know what this is gonna be. So that's 5, that's I. So you're gonna have 5I times the square root of 2. All right, so these numbers right here are considered pure imaginary numbers. So anything that looks like, so say if I have any number B, and it looks like BI, where I is the square root of negative 1, and B is just some number. So let's say B is, you say it's some number. Then this is what's called a pure imaginary number. Let's do some exercises just to see if, in fact, we can get these done. All right. Let's go with these. I'll do this first one. You guys can do the next two. So here, the square root of negative 121 actually breaks up into negative 1 times 121, right? 121 is a perfect square. If I take 121 out, it becomes 11. If I take negative 1 out, it becomes I. So for the most part, well, actually, just so for the sake of explanation, I'll split it up even more. That's square root of negative 1. This is the square root of 121. So this becomes I. That becomes 11. So what I have here is 11I. So how about this? Why don't you guys pause the video, try to do those two right there, and come back, unpause, and see if, in fact, how you're doing. All right, go ahead. All right, hopefully that's what you got for the next two. Obviously, it doesn't take long. You just split up all the numbers, separate the negative 1 from everything, separate out the perfect square, and then take those things out. So you should have got 4I times the square root of 2 for the second one, and for the third one, you should have just got 10I. That's the whole idea behind simplifying those. So if, in fact, we're adding them, say, for example, I wanted to add those together, they add just as if I is a regular old variable. And the same thing with square roots. So if I have these two, numbers right here, what we can imagine is, since they have like radicals, we can combine those together. So really, it's just like combining them as if they're variables. So for the most part, it's just 1 plus 3I. So what you should get is 4I times the square root of 2. On the other hand, if in fact I'm subtracting these two, now mind you, these have solutions now. The square root of negative 16 is just going to be 4I, and the square root of negative 49 is going to be 7I. 4I minus 7I is just going to give you negative 3I, just as if it's a regular variable. You should be fine with that. So that's what happens when you add them together. So how about this? Try these on your own, see how far you can get, and come back, unpause the video after you're finished with them, just to see what I got and match up your answers. So go ahead and pause the video now. Once you're finished, these are the kind of problems, this is what it should look like. Notice I broke it all the way up, and once I finished breaking it up all the way, I took the negative 1 out along with the perfect squares. The I usually, as you can notice here, the I usually comes last. The imaginary number comes after everything, even after the variables. You'll see it actually over here, how it actually comes last. So This one you should have got 3I times the square root of 6. This one you should have got 3t squared I times the square root of 2t. Watch how I break it up and adjust it if in fact you did not get what I got. All right, so that's about as much as we're going to do today. We'll do some more in class. I will see you guys later.